Today what we're going to talk about, guys, is ordering integers and other rational numbers. So basically we're going to say, how do I put a number in order in comparison to other numbers? We're going to start with a little thought exercise. And it's going to start by graphing a few different numbers. So let's graph, if I can move this, there we go, the number 7 and its opposite on the number line. So where would 7 be? On the right. So again, when I graph a number, the dot should be directly on the number line, not above, not below. It basically should be closed in because I'm showing that that is where the number is. And it should be right at the 7. Where would its opposite be? Solo? 7 to the left, or negative 7. So I put the dot right there. We're also going to graph the number 5 and its opposite on the number line. So where would 5 be? 5 on the right. Its opposite would be?
Negative 5 on the right.
Negative 5 on the left. Make sense? So let's talk about comparing these numbers. Where does 7 lie in relation to 5? In other words, if I start at 5, how would I get to 7? Layla? If I'm starting at 5, how do I get to 7? Do what? Which way? I move 2 to the right. So 2 units to the right. Now, where does 7 lie in relation to 5? In other words, it's saying, I want to know where 7 is, and it's telling me where to start. So it's saying, don't start at 0, start at 5, tell me how do I get to 7. Make sense? Now, where does the opposite of 7 lie on the number in relation to the opposite of 5? In other words, if I start at negative 5, how do I get to negative 7? What do you guys say? 2 units to the left. Is there anybody who doesn't see that? Okay? So I'm thinking about 2 numbers. They're both positive. In other words, they're going to be to the right of 0. The first number lies to the right of the second number on the number line. Does everybody have the picture so far? So what can I say about the location of their opposites? So the numbers I'm thinking of, and I'm not going to tell you which 2 they are. I will tell you it's between 1 and 10, the 2 numbers. But the second number, the first number is right of the second number. So that means the first number is what, bigger or smaller? Bigger. So what can I say about their opposites? So it's going to be further to the left. So the opposites will be further to the left. Does that make sense? Apparently easier for me to say than to write. Which part's confusing? How do I get to it? Because on the right-hand side, the bigger number it is, the further right it is, correct? So if I look at their opposites, a number that's further right on the positive side is going to be where on the opposite side? Further to the left, meaning that it's going to be more negative or smaller. Make sense? So if I'm looking at two numbers, their opposites are going to have the opposite relationship. If it was bigger on one side, it'll be smaller on the other side because it's going to be further down. Okay, 2 record low temperatures in the town of Maine are minus 20 for January, minus 19 for February. Order the numbers from least to greatest and explain how you arrived at the order. Okay, so we're going least to greatest. Which number is smaller, negative 20 or negative 19? Jaden? Why? Good. Negative 20 is further to the left. Hey guys, hint, get used to that phrase. We're going to use that a lot today. Because when we're talking about the relation of numbers, it really is the further left on the number line is smaller, further right on the number line is bigger. So that's going to be your explanation for about half of today's problems. Make sense? Good. Go ahead and turn the page. Okay, here, for each problem, order the rational numbers from least to greatest by first reading the problem, then drawing a number line diagram, and finally explaining your answer. So there are several parts to this, aren't there? Okay? This is where we moved you guys into groups. One advantage of that is we're going to allow you guys to talk with each other and work together on these. Okay? Okay, so we have two people. John ran in 9.2 and 9.18 for Jackie. Because the directions say draw the number line, I'm actually going to do that first because, quite honestly, it is easier if you've got the number line to visually see where they are. A lot of students were questioning, how do I draw a number line when it's 2 decimals? Well, you just make your number line in decimals is the easy way to do it. So for me, I'm just going to do 3 intervals. I'm going to do 9, 9.1, and 9.2. Special shout out to Porter for reminding me I already did all this without recording it, so we went back and did this again. And now I'm just going to put those numbers on here. So our first one, 9.2, is really easy. It's going to be right here. So that's John's time. Jackie's is 9.18. So where's that going to be? Just a little bit before it, right? There's Jackie. So now I've done the number line portion of the directions. So who ran the mile in less time? David?
It was Jackie.
Why? Excellent. She ran in less time because it is left of John's. Perfect. That's exactly, guys, I want you to get used to this. This is how we describe less or greater than is the relative position on a number line. Further left is smaller, further right is larger. Or if I'm doing a vertical number line, further down is smaller, further up is bigger. Does that make sense? Okay. Number 3, Miss Rodriguez. She gives bonus points for tests of outstanding writing, deducts points for answers not written correctly. She uses rational numbers to represent their points. She wrote the following. Student A had minus 2 points. Student B had minus 2.5. Did student A or student B perform worse on the test? Again, because I have to have a number line anyway because of the directions, I'm going to go ahead and do one with negative 2, 2.5, 3. Negative 2 is going to be student A. Negative 2 5/10 is student B. So who did worse? Why? Perfect. Student B did worse because their score is further left. Because their score is more negative than student A. And on the negative side, the larger the number, the larger the value of the number, the smaller it is. Okay? A carp is swimming approximately 8 1/4 feet beneath the water surface. A sunfish is swimming approximately 3 1/2 feet beneath the water surface. Which fish is swimming farther beneath the water surface? Okay, now, when we do elevation stuff, I actually prefer a vertical number line, to be honest with you. So on this one, I'm actually going to do a vertical number line. Okay? I'm going to have 0 for my water surface because they're both swimming beneath. Given the intervals we've got with negative 3 1/2 and negative 8 1/4, I'm going to go by 2s. And The first row we had was the carp at negative 8 1/4, meaning just a little bit past the negative 8 is going to be the carp. The sunfish at negative 3 1/2 is going to be about 3/4 of the way down here because I have an interval of 2. So which fish is further beneath the water surface? Why?
Because he's more downward than sunfish.
Carp is further down on the number line.
Or because his negative elevation is greater than sunfish.
Okay?
Or even not that.
It gets a little harder when you try to rephrase it other than just put in reference to the number line, right?
Yeah.
That's why the number line makes it easy, guys. Okay, next one. We're doing a card game. Henry, Janan, and Clark are playing. The object is to finish with the most points. Scores at the end. Henry had a -7, Janan had 0, and Clark had -5. So who won? Who came in last? Use a number line model and explain. So there's several parts to this, aren't there? So again, since we have to use a number line, that's the first thing I'm going to do, because if I got to do it anyway. That being said, honestly, if I don't have to, most times I'm not going to use a number line. But we do follow directions, right? Otherwise we lose points. So on my number line, because I've got 0 as my largest number, I'll make sure that one's in there. -1, 2, 3, 4, 5, 6, 7. Need to extend my line just a little bit. Okay? Excuse me. So we had Janan at 0. We have Clark at -5. And we have Henry at -7. So, who won?
Dan.
Why?
Because he's the most to the right.
So Janan won because he's furthest right. Who lost?
Henry came in last.
Because?
His was first and the last.
Is there anything else we need to do for this question?
Saying how we arrived at our answer?
Have we done that?
Oh, yeah. Never mind.
We did that as part of our explanation of who won and lost, right? So we kind of killed 2 birds with 1 stone by giving a complete answer. So again, have we done everything we needed to?
Mm-hmm. Probably not. Yeah, probably not since we're acting up, but we did.
We did. Not true. That's why sometimes I ask even when you did do it all. Because otherwise, you guys start to get into bad patterns. Okay, our next part. Now we're on notes. So go ahead and turn to the next page. This is why we photocopied the pages even though they're in your module, because we wanted to give these additional notes as well. And this just makes it easier rather than switching back and forth between. So to compare integers, we can compare both the blank as well as the blank or size of the numbers, as well as where they're located on the number line. So what things do you think we are using when we're going to compare integers? The value would be the size. So we say the size, we're really talking about the value of the number. So what else would I look at? What do we call that? Positive, negative. So how do I indicate positive, negative?
Left and right.
Okay? Sign, saying is it positive or negative? Because will there ever be a positive number that's smaller than a negative number? No. Will there ever be a negative number that is bigger than a positive number? No. So if I'm doing a comparison, I can use sign right away, right? I know all positives are bigger than all negatives. I can also use the value on the positive side The higher the value, the bigger the number is. On the negative side, the higher and this is where I'm technically not saying it right, but the more negative a number it is, the smaller it is, right? Okay? But we need to understand that. These two lines right here is everything for today's lesson. If you guys understand this, you have today's lesson down. Greater numbers are graphed farther to the right. Lesser numbers are graphed farther to the left. That's really everything that we need to understand for today. Now, putting it into practice is the rest of what we'll be practicing. Again, just a quick review, because we did this last time when we talked about integers. When I put them on a number line, the numbers go below the number line. 0 will be the middle. Positive numbers are to the right of 0. Negative numbers are to the left of 0. The number next to 0 is going to be 1, unless my interval is different, but then whatever the interval is, we go up by that. But 1 going up and 1 going down. So we basically count from 0 in both directions. To compare integers, we need to remember a few things. If I see this mathematical symbol, what does that mean? How do I read that? Solo? No, that is actually less than. Devin got it right the first time. So now, which does that one mean? There's the greater than. Okay. And Miss Caroline is no longer here, so I can say this again, because I already asked Miss McShann if she does agree. For me, the easy way to think about this is the alligator. The alligator is always hungry. He wants to eat as much as he can. So the side with the mouth open that the alligator is eating is always the bigger number. So if the bigger number is on the right, that means the alligator is eating that side. If the bigger number is on the left, he's eating that way. However, the way I say the sign is opposite. When I think about the sign, I look at the sign itself. There's less on this side, right? So this is less than this side. There's more on this side, so this is more than this side, or greater than. You can say more than or greater than. Those are basically interchangeable. So when we graph 2 points and start comparing them, we can actually use either one of those comparisons with any set of numbers. Okay? Our first set we're going to talk about, let's do -5 and -2. So first we can graph them to help us understand visually where they are. -5, -2. So if I'm going to say less than, which number is going to come first? Which number is less than the other? Caden?
-5.
Is less than -2? Are you sure about that? Does anybody want to say something different on that?
No, that's good. That's right.
That's correct.
Stop trying to make me second guess myself.
I'm trying to make you confident in yourself. Be ready to defend your answer. Why would you say -5 is less than -2? Really? Because it's further to the left. It's literally that easy, guys. Today's lesson is that easy. It's further to the left, it's less than. But I can flip the sign around. Now what do I say? So? -2 is greater than -5. Are both of those correct?
Yes.
Yes. Even though the order is different, because the symbol between is different, those are both correct. Okay, what if I use -4 and 3? If I talk about less than, how would I say that one, Roman? Rowan? Which one is less, the -4 or the 3? So I would say -4 is less than 3. Or I can reverse it, Gian, and say?
You can say 3 is greater than -4.
Thank you for saying it properly. Well done. 3 is greater than -4. When it's positive and negative, that relationship should always be very simple. Negatives are always going to be smaller. What about when we throw 0 into the mix, though? -3 and 0. David? Good. Thank you for correcting yourself when you saw what the symbol said. So negative 3 is greater than 0, is less than 0, or 0 is greater than negative 3. Everybody tracking okay so far? Good. Let's go on to the next one. Now here's where we order integers if we have an entire list of integers. And I'll be honest, in these cases, a number line actually can help you, especially if they build it for you, so I don't have to draw it myself. But if they give me a number line, then it's super easy, because all I need to do, well, let's go through the instructions first. You can use a number line to order a set of integers. Integers can be ordered from least to greatest, or from greatest to least. Be sure to read what the question is asking for carefully. Guys, this is the single biggest thing students miss. Because honestly, this isn't really hard. But if you don't read it carefully, you're going to put them in the wrong order. So in this case, we're going least to greatest using the number line. So our first step is actually going to be putting the numbers on the number line. So I just go through in order. So I say negative 9, and I plot it on the number line. Then we go to 6. That's all the way over here. Negative 3, right here, just on the negative. And 0 right in the middle. So now, to put them least to order, least to greatest, using my number line, which number is the least? Negative 9. Then what?
Negative 6. Oh, no, negative 3, sorry.
Say negative 6 doesn't even have a dot. Then what?
0.
Then 6. And just because we went through this earlier, when I see these brackets around it, guys, that's a mathematical symbol for saying this is a set of numbers. So technically you should have, but I'm terrible at drawing it, so I don't mind if you guys aren't great at it either. But technically you should put the set marker around it as well. Okay? So there is our set from least to greatest. Everybody agree?
Is that 2/5?
What?
What is that?
That's the bracket symbol.
Oh, that looks nothing like that.
I know. Did you not just hear me? I just said I'm not great at drawing it, but technically it should be there. Now, can we also order them by comparing the signs and values? In other words, do I have to have a number line if they don't tell me to?
No.
No, I can start with the values, right? Technically, start with the signs and then go to the values. So if I look at the signs, I have two negative numbers, right? So I know they're going to be on the least side. Then I look at the values. Which one is going to be smaller, negative 9 or negative 3? Negative 9, because it's further left. So using the values, I can say negative 9, negative 3. 0 is always going to be in the middle between positive and negatives. And then the only number left is 6. So did I have to use a number line? No, you can do it without. You can just use the signs and the values to do it. Make sense? Awesome. Go ahead and turn the page. Okay, here's your chance to really get working on your own. Okay? So we'll basically give you almost right up to lunch here to go ahead and knock out this entire page. Couple clarifications. First part, all you need to do is ABC. Ignore the jump pages. We're not switching back and forth. Here in the box, you're going to put either less than, greater than, or equal to. Once you determine what the relationship is, you're going to ignore the boxes from here down. That's basically just a formatting error. Use the space underneath the question to answer them. Okay? So we'll give you guys 8 minutes, and then we'll cover this when we come back. Okay, guys? Quiet down, please. Recording's going. Yeah, he went to get a drink. Okay, which list is least to greatest? A, B, or C? C. Starting at the negative. That's positive, so you know that's wrong. 2 to 5, that went the wrong order, so you know that was wrong. Only left one option. Increasing. Increasing means what? Up. Small to big, right? So, which one is least to greatest? B. This one is greatest to least. This one, those two are backwards. And the next one, which one is decreasing, meaning what? Going down, greatest to least. So that would be also B. This one, they mixed up the 7 and the 8. The last one is the opposite. Okay, let's compare. -6, -5, my sign was?
Less than.
Less than. Absolute value of 46 and 46?
Equal.
Equal, they're both 46. Absolute value of -65 and 65? Equal. -8 and 0. Less than? 47, -28. Any positive will always be bigger than any negative. -7 and 7? Pretty easy, right? Okay, now some thought questions. Does every integer have an opposite? Devin?
Yeah, because the opposite of 0 is 0. As you have previously
T?
I was going to say no because he's right or wrong.
I was going to say kind of a combination of the two. Technically, you're right, but I agree that 0 is a caveat. So I would say yes, except 0, which is its own opposite.
But that would mean that the answer is no, because it says every integer.
Yep.
So you can't have an exact.
Yeah, you can. Because as a general rule, every number has an opposite.
Okay. Makes sense.
The general rule is there's an opposite for every number. 0 is the only exception. So when you're talking an infinite number of numbers, and there's one exception, I would say that's a general rule of yes.
Okay.
Does a decimal number, such as 5 4/10, have an opposite?
Hey, excuse me, I thought you said we weren't supposed to do that. You are? No, you're supposed to
Yeah.
do the opposite.
You're just not supposed to use boxes. Yes. When is the absolute value of a number the number itself? Devin?
All of the time, all of the time, except for when it is not asking for the opposite, or except for when it is asking for the opposite of the absolute value.
No.
Everybody's wrong.
Sean?
Whenever the number is a positive and 0.
Any positive number or 0? Then it's the number itself.
Oh, I see.
So the what of a number is its distance from 0 on a number line. What do we call that? Sean?
Absolute value.
The absolute value. That's the definition we gave you. And two integers are what if their sum is 0? What term do we use for them? Devin?
Opposite.
Good. Two integers are opposites if their sum is 0. In other words, 2 and -2, 10 and -10. If I put them together, they're always going to equal 0. Any questions on that page? Okay, let's go ahead and turn the page again. Okay, we're going to have to go a little quicker because we're down to about 20 minutes. We want to make sure we get through as much as we can since what's not done is homework. So Sam has $10 in the bank. He owes his friend Hank $2.25. He owes his sister $1.75. Consider the three rational numbers related to the story. Write and order them from least to greatest. So first thing we need to do is write them down so we actually have the integers. So 10. He has $10 in the bank. What number would represent that? 10, because it's a positive. What about he owes Hank $2.25?
-2.25.
Good. Negative $2.25. And he owes his sister $1.75. Negative $1.75. Now, again, pay attention to what they're asking. This is literally the biggest part you guys will miss. You don't pay attention. You get into a habit where you're doing the same thing every time, then they'll reverse the list on you, and you'll mess it up. What am I doing on this one? Least to greatest. So what is the least of these numbers? Solo?
-$2.25.
Okay. So he says we're going to start with negative $2.25, then go where? Caden? Negative $1.75. And then we'll finish the list with $10. Is everybody good with that list? Anybody have a problem with it?
Nope.
Good, because that's in the right order. So make sure you do something to signify that that is actually your final answer, because we had to do the list first, I prefer a double underline. That's just that's how I was trained. But circle it, underline it, something to set it apart so we know that's your answer. Now, for each problem, list the rational numbers that relate to each situation, then order them from least to greatest. Explain how you made your determination. So there's actually several steps to this one again. Do I have to draw a number line?
No.
No, it doesn't say to. So you don't have to unless you want to. But we do need to write these out. So during their most recent visit to optometrist, Kadisha and her sister Beth had their vision tested. Kadisha's vision was -1 and 50/100ths in her left eye. Her vision in her right eye was the opposite. So what would the opposite be? Plus 1 and 50/100ths. Beth's vision was -1 in her left eye and plus 25 in her right eye. So we've got them all. Now we need to order them from least to greatest. So what was the least of these numbers? David? -1.1 and 50/100ths. Then what? -1. Then? So we did that one, we did that one. So 25/100ths. And finally, 1 and 50/100ths. Everybody good with that list? Anyone have an issue with it? Just make sure no one has an issue. Good, there's our answer. Have we done everything we were supposed to?
No, you have to explain it.
No, we haven't. We have to explain our reasoning. What's our reasoning?
1.50 is furthest to the left, and negative 1.50 is furthest to the left. Plus 1.50 is furthest to the right. And then the other's more in the middle.
Okay. So another way to say it, we could have said we just went from left to right. So do I have to have a physical number line to reference it? No. We could have referenced a mental number line where we just said we went from left to right, smallest to greatest. Okay, there are 3 pieces of mail in Mr. Thomas's mailbox. Oops, 3, sorry. Bill from the phone company for $38.12, a bill from the electric company for $67.55, and a tax refund check for $28.59. A bill is money you owe. Tax refund is money you receive. So that helps you understand the positives or negatives of this. So the bill for for $38.12 would be what as an integer, Rowan? The bill going to be positive or negative? Negative. So negative $38.12. A bill for $67.55 is going to be negative. And a refund check of $25.89 is going to be positive. I need to go from what? Least to greatest or greatest to least? Least to greatest. We're still under the same set of directions. So of these numbers, which one is the least? Layla? Okay, negative 67.55. Very important you include the negative. So that crosses that one off. Then what? Good. Negative 38.12. And finally, 25.89. Is everybody good with that list? Okay. In our, how did we do it? We went from right to left. Went from left to right. On the number line. Any questions so far, guys? Good. Let's go ahead and go to this one. Actually, you know what? We're going to skip this page. Go to this page. So I want to make sure we get through this one. Don't exit out yet because we might come back to it, depending on how time goes. But last class, we barely made it to this one, and I want to make sure we have time to go through the homework, since homework is for everybody. Okay, for each of the relationships below, write an inequality that relates to rational numbers. I'll be honest with these, a lot of these, it's actually easier if you'll go through and write the numbers first, and then you can put in the less than or greater, the inequality sign. But do whatever works for you. A lot of that's why we're marking our text. So 7 feet below sea level is farther below sea level than 4.5 feet. So the numbers on that, 7 feet below would be what number? Good, -7. 4.5 below sea level would be -4.5. So what symbol would go between them? Less than, greater than, or equal to?
Greater than, greater than.
So -7 is greater than -4.5. Everybody good? Okay, let's do our next one. 16 degrees Celsius is warmer than 0 degrees Celsius. So 16, I would just write 16. 0, I would write 0, the sign in between. Not by your logic from the first one. I asked if you guys were okay with it. Everybody said you were okay. I asked who, if everybody was okay. Did anybody raise their hand?
I was thinking
But you didn't say it.
I was thinking.
Well, I'm glad you were actually thinking for once, Caden. Guys, the first one was wrong. -7 is less than -4.5. That's why I went almost all the way through the next one to see if anybody would speak up and say something. Nobody did. Remember, on the negative side, the bigger the number is, the smaller it is, because it's further left. Okay, our next one, 3½ yards is less than, that actually should make it easy, than 5½ So 3½ is less than 5½ Everybody good on that one? Did we do it right this time? Okay. No?
No, we did it right.
Okay. Well, David said no, so I just want to make sure. So a loss of 500 in the stock is worse than a gain of 200. So a loss of 500 I would show by the integer -500 is worse than, so that means which symbol? Less than. A gain of 200 would be 200. Does that look right?
Yeah.
Is everybody sure again? Okay. Here's why I wanted to get to this, because we don't have to limit our inequality statements to just two numbers. We can actually string inequality statements to show a relationship among multiple numbers. So a test score of 64 is worse than a test score of 65. A test score of 65 is worse than a test score of 67.5. So I can now make just one inequality statement that includes all of these numbers. So what number would I start with? Score of 64, what number would that be? 64 is worse, so what symbol is that? Less than 65. And 65 is worse, or what symbol? Less than 67.5. Does that make sense? Okay, so that is something you will do actually quite often, especially if you've got strings of numbers and you're asked to make an inequality statement. Inequality statement, guys, just means I'm adding this less than or greater than symbol into it. And I can do it more than once. So in December, the total snowfall was 13 2/10 inches, which is more than the total snowfall in October and November, which was 3 7/10 inches and 6 1/1500 inches, respectively. So this one actually is going to require us a little bit more work. Because what am I going to compare? What about the snow? Okay, the inches of snow, but what am I actually comparing? Totals. So what's my total in December? 13 and 2/10. Okay, and it says it's more than the total of 3 and 7/10 and 6 and 1500ths. So how would I find that total? Add them. So I add 3 and 7/10 and add it to 6 and 1500ths. Again, remember when we're adding, we make sure our decimal places line up. If you have to put a 0 up there, you can, but I know there's nothing there. So nothing in 5 is 5, 7 and 1 is 8. My decimal comes down. 6 and 3 is 9. So is more than 9 and 8500ths. Does that make sense? Everybody tracking so far on the first 6? Okay, for each of the following, use the information given by the inequality to describe the relative position on the number line of a horizontal number line. Yes? 3 and 7/10 and 6 and 1500ths. Okay, so if I'm talking about relative position, where's -2 in relation to -1? -2/10, sorry, to -1/10. On a number line. -2 is more, -2/10 is more to the right. -2/10 is more to the left than -1/10. Okay. So -2/10 is left of -1/10. Somebody agree with that? Okay, what about our next one? 8 1/4.
It's right up. Right up. -2 is right. Oh, wait. Never mind, I'm confused.
No, it's right, because 1 does.
No,
No, it's left.
-2 is left of -1. -1 is right of -2.
-2/10
Yeah.
and -1/10, not 2 and 1.
I'm still confused. Sorry, I'm tired. Let's just go to nap. Let's just take a nap.
Oh, that sounds so beautiful right now, but I can't. We still got 15 problems to get through. Okay, what about our next two set? 8 1/4. How's that compared to -8 1/4? So it's going to be right. So 8 1/4 is right of -8 1/4. What about -2, 0, and 5? Ooh, now we got 3 of them. Think you can handle this one, Devin? Even if you are tired?
Yep.
So what do we say?
-2 is left, is left of 0, which is left of 5.
Awesome. I love the way you strung that, which is left of 5.
Is it okay if we say greater than or less than instead of left or right?
Because it's what relative position, that needs left right.
Okay.
Because less than greater than is the relationship. The relative position is left right.
Okay.
Or up down if I'm doing a horizontal. What about -99 and -100? Stella? Oh, welcome to the right page. So where's -99 in relation to -100? Stella? Is 99 right or left of 100? Negative, sorry. -99 left or right of -100? Olivia?
99 to the right.
Yep. It is left. It's right because it's bigger. And our last one, -7 and 6/10 is, yes?
-7 and 6/10 is left of -7.5, which is left of -7. Cancel.
Are you guys understanding these problems? Does it make a little more sense once you see all this written out? Okay, our next set, 3 integers between -4 and 0. Pay attention to the symbols in between. So I'm going to start on the low side or the high side? The symbols are less than. So I'm going to start on the low side or the high side?
The low side.
So which is low, -4 or 0?
-4.
So start on the -4 side. So it's got to be between. So -3, -2, -1. 3 rational numbers between 16 and 15. Rational means I'm going to be making decimals or mixed numbers. So between 16 and 15, again, pay attention to your sign. I've got less than. So I'm going to start at the 15 side or the 16 side? 15 side. So we'll go with, for example, 15 and 1/10, 15 and 5/10, and 15 and 8/10. 3 rational numbers between -1 and -2. Again, starting on the low side. So which side am I starting at? -2. So I want a number that's going to be closer to -2. That's a decimal. So we'll go with -1 and 8/10, -1 and 6/10, and -1 and 3/10. 3 integers between 2 and -2. So again, I've got less than symbols. So which side am I going to start at? -2. So the next integer is -1, then 0, then 1. Okay, turn to the next page. Here's where your homework starts. Okay. Number 1, pretty simple. Just make sure that you realize what par is. We had that whole discussion the other day. Par is the number of strokes you're expected to take. Then they give you a chart with a bunch of kids. Make sure you pay attention to what the questions show. Again, focus on what the order looks like, least to greatest. This one, it gives you the numbers, so I would actually recommend just write the numbers above them or below them, take your pick, and then see which list has them all. Same thing with number 5. Number 6, they've given you a chart. Understand, warmer means the temperature is higher than that. Colder means it's lower than that. Okay? And then number 8 has another table, which means advance further. Remember, positive yardage is good, negative yardage is bad, and which teams lost the most yard, in other words, which are the most negative. Any questions on that page? Those 2 pages, actually. Okay, go ahead and go to the very last page. And cross it off. I'm not going to make you guys do this one. Honestly, this one caused a lot of troubles last year when we did it, and we didn't get as far in class today as I wanted to. Yep, you don't have to do that page. If you want some extra practice, you may do it if you want to, but you are not required to do that page. And then the other page that we skipped, you guys can cross that one off as well. We didn't get back to it. If you want to know the punchline, you got to do it. I'm not giving you the punchline. Okay, guys, any questions on the homework or anything that we've covered today?